Zhuque 3. Zhuque 3, ZQ3, is an active, two-stage, medium to heavy partially recoverable launch vehicle made of stainless steel and powered by liquid methane fuel. It is the third in a series of orbital-class launch vehicles developed by LandSpace Technology Corporation, LandSpace, a Chinese commercial space launch provider based in Beijing. The maiden flight of Zhuque 3 occurred on December 3, 2025. Although LandSpace's attempt to achieve first-stage recovery during the rocket's maiden flight proved to be unsuccessful, the company nevertheless hopes to progress towards the milestone of first-stage reusability in the future. The eventual Zhuque 3E will be equipped with 9 Tianke-12B engines, 5 of which can gimbal and 4 which cannot. The first stage is designed to be recoverable and reusable for up to 20 launches. The second stage will use a TQ-15B engine. The rocket will be 76.2 meters, 250 feet, in length, 4.5 meters, 15 feet, in diameter, and have a liftoff weight of 654,500 kilograms, 1,442,900 pounds. Its planned payload capacity to low Earth orbit, LEO, is about 21,300 kilograms, 47,000 pounds, in expendable mode, 18,300 kilograms, 40,300 pounds, when the first stage is recovered downrange, and 12,500 kilograms, 27,600 pounds, when the first stage returns to the launch site. Zhuque 3, the initial version of the rocket which was used on the rocket's first flight, is less powerful in performance and specifications than the mature version of the launch vehicle, the Zhuque 3E. The Zhuque 3 is about 65.9 meters, 216 feet, in length with a mass of about 550,000 kilograms, 1,210,000 pounds. It uses slightly lower thrust engines on each stage, the TQ-12A and TQ-15A. On January 19, 2024, LandSpace conducted a successful vertical takeoff and vertical landing, VTVL, test using the Zhuque 3 VTVL-1 test vehicle at Zhuque Satellite Launch Center, JSLC. The test stage, powered by a single Tianke-12 engine, flew for approximately 60 seconds and reached a height of about 350 meters, 1,150 feet. LandSpace reported a landing accuracy of about 2.4 meters, 7.9 feet, and a touchdown speed of approximately 0.75 meters per second, 1.7 miles per hour. Additionally, the company had previously announced plans to develop a 200-ton class, 440,000-pound class, full-flow staged combustion engine BF-20, which is expected to be ready by 2028 for a future version of Zhuque 3. On September 11, 2024, the Zhuque 3 VTVL-1 test stage completed another successful vertical takeoff vertical landing test at its Zhuque Satellite Launch Center. The test flight lasted about 200 seconds and achieved a maximum height in excess of 10 kilometers, 6.2 miles. The flight also featured a mid-air engine cutoff test at about 113 seconds after liftoff and an engine reignition test about 40 seconds later when the test stage was at a height of about 4,640 meters, 15,220 feet. This engine cutoff and reignition sequence during a VTVL attempt represented a first for any Chinese rocket manufacturing entities. During the period when its engine was not in active operation, the test stage employed a cold gas attitude control reaction system in addition to 4 grid fins to control its gliding descent. The test stage completed its landing sequence at a concrete pad located about 3.2 kilometers, 2 miles, away from its launch point. The precise landing spot was 1.7 meters, 5.6 feet, away from the nominal center of the landing pad. On June 20, 2025, LandSpace conducted a static fire of a Zhuque 3 booster test article, not a flight-ready booster, at the Zhuque Satellite Launch Center. The test was performed on the actual launch pad for Zhuque 3, similar to how Starship's Super Heavy booster is static fired on the Orbital Launch Mount, OLM. For this test, the article was filled with propellant, partly to mimic in-flight conditions but likely also to prevent an accidental flight. The test article featured 9 TQ-12A engines, generating a maximum of 7,541 kilonewtons, 769 tons force, of thrust during the 45-second static fire. The 5 engines which can gimbal also performed tests. In an official statement, LandSpace hailed the test as completely successful and instrumental to the success of Zhuque 3. From October 18 until October 20, 2025, LandSpace conducted a full-scale propellant loading rehearsal and first-stage static fire test in preparation for the maiden launch of Zhuque 3. Next, the company will proceed to conduct vertical integration rehearsals involving the second stage and the payload fairing before returning the rocket to relevant test areas for inspection and maintenance. The first launch of the base Zhuque 3 occurred on December 3, 2025 at 4 o'clock Coordinated Universal Time. The payload successfully reached orbit, but the first stage booster experienced an anomaly during the final recovery phase and crashed near the planned landing site. In a video, the booster appeared to catch fire while still in the air as the engine were supposed to ignite. According to the Xinhua news agency, an abnormal combustion occurred during the recovery process, thereby preventing a soft landing on the recovery site and resulting in the failure of the recovery test. On December 6, 2025, LandSpace announced that despite the unsuccessful attempt to recover the first-stage booster on December 3, 2025, the company nevertheless succeeded in verifying the structural thermal protection system, overall aerodynamic layout design, and attitude control capabilities of the first-stage booster during its supersonic re-entry aerodynamic glide phase. The December 3 recovery attempt also allowed the company to verify the first stage's composite attitude control strategy, which involves the use of a cold gas reaction control system combined with the employment of grid fins. Finally, the booster landing attempt gave LandSpace sufficient data to verify the precision of the booster's recovery guidance algorithm during both the re-entry ignition phase and the re-entry glide phase. According to China National Radio, Zhuque 3 is expected to launch the new reusable Haolong cargo space shuttle built by the Chengdu Aircraft Design Institute, CADI, an arm of the Aviation Industry Corporation, AVIC. The cargo space shuttle is one of 2 lower-cost resupply vehicles selected by China Manned Space Agency, CMSA, to provide greater cargo return capabilities and resupply redundancy for the Tiangong Space Station, TSS. The Zhuque 3 is also expected to begin launch missions for China's Guowang broadband communications megaconstellation.